This video is for our second unit, Solving Inequalities, Day 3 notes, all about special solutions. If you recall back in our Solving Equations unit, we had a special solutions lesson. And the first two examples, A and B, demonstrate what happens with special solutions. In example A, we distribute, we combine like terms. On the left side, we have 4x plus 7. On the right side, we have 4x plus 7. When you start to move all of your x's to the same side, the x's cancel out. We're left with the statement 7 equals 7. Since that's true, we call that infinitely many solutions, or IMS. In example B, again, you distribute and you combine like terms. We have the statement 3x plus 6 equals 3x plus 7. When you cancel your x's out, you have the statement 6 equals 7. That's no solution because it didn't make any sense. And what made these two examples special is that the variables canceled and we're just left with constants for answers. That scenario can happen with inequalities as well. So if we get a statement such as this, 4 is less than or equal to 4, it's a true statement. That's an IMS scenario. The entire number line gets an arrow, left to right, and there's no dots. If you have a false statement such as 4 is greater than 5, then the number line is left blank. I sometimes put an open dot on 0 just to demonstrate I'm purposely not putting any marks on the number line. That way I know I haven't forgotten to make my number line. So as we go to our examples, example number 1, distribute on the right-hand side. Move all of your x's over. Our x's don't cancel. We end up with negative 2x plus 4 is greater than 6. Subtract 4, divide by negative 2. We divided by a negative, so that means we had to flip our inequality sign with the statement x is less than negative 1. So we make our number line, put an open dot of negative 1, show our arrow pointing to the left because all the numbers to the left of negative 1 are smaller than negative 1. If we move to example 2, you combine the like terms on the right-hand side, we end up with 5x plus 4. Subtract your 5x over, so we can move all of our x's to the same side. We end up with the statement that negative 1 is greater than 4. Well, that's not true. That's considered no solution. So you'll notice I just made a basic number line, and I put an open dot on 0 just to let myself know I didn't forget to make my number line, but there's no numbers that make the solution true. Example 3, if we can distribute, we get 4x minus 24. Combine the like terms on the left, that gives us negative 24. If we subtract 4x over to the left, so we can put all of our x's on the same side of the inequality sign, we end up with negative 24 is less than or equal to negative 24. That's a true statement. So I make a basic number line and put an arrow going over the entire number line. In number 4, you distribute, you start to combine your like terms. We end up with negative 12x plus 28 is greater than or equal to negative 12x plus 30. Subtract our x's over to get all of our x's on the same statement. On the same side, we end up with the statement 28 is greater than or equal to 30. That's false. So this is a no solution. So we make a number line, leave it completely blank, or just put an open dot on 0. Number 5, you distribute your negative, gives us negative 11x plus 5. You distribute the negative 4, gives you negative 12x minus 4. You combine your like terms on the left, you get negative 6x minus 3. Combining like terms on the right gives you negative 6x minus 4. Add 6x over, so all of our x's move to the same side. That means that our x terms fall out. We're left with the statement negative 3 is less than negative 4. That's false. So this is no solution. Open number line, open dot on 0 to say nothing works. Number 6, you combine the like terms on the left, giving you negative 8x minus 12. Combine the like terms on the right, gives you negative 8x minus 2. Add your 8x over to move all of your x's to the same side. We end up with the statement negative 12 is greater than negative 2. That's false. It's no solution. So we make an open number line. Number 7, combine the like terms on the left, giving us 8 minus 9n. Combine the like terms on the right-hand side, gives us a negative 11n. I decided in this case to take my 9n and move it over to the right since there's only one constant term. When I do that, I end up with a negative 2n on the right-hand side. It means my n's didn't cancel. I need to keep solving. So divide by negative 2. Because I divided by a negative, that means I have to flip my inequality sign. So I have a statement I can actually graph. Negative 4 less than or equal to n. So put a solid dot on negative 4, and I want negative 4 to be smaller than some number. I know negative 4 is smaller than 0, so I draw my arrow pointing out towards 0. In example 8, you distribute, giving you negative 10x minus, or negative 10 minus 8x. You distribute the 6, giving you 18 minus 12x. If you combine your like terms, on the left side we get negative 10 minus 12x. On the right-hand side, we get negative 12x plus 12. I want to move all of my x's to the left, so I add 12x over. That gives me the statement negative 10 is less than 12. Well, that's true. So I make a basic number line, put the arrow going over the